session, you should discuss on the assignment. I think, of course, you don't have time to complete your assignment. Therefore, please use this 2 hour session of the tutorial to discuss. Okay. In this breakup session, I will visit each group and see your participation, um, your discussion, and if you have anything, you can ask me. So I think you can get in your respective group from now. Okay. And before you join the group, please, if you have anything, we can discuss in general before we specific in the in your topic. Do you have anything to ask regarding to the assignment? Ada tak soalan nak tanya? Okay. Okay, this is the topic for each group. Okay, the first one, nickel aluminum alloy, copper aluminum, copper stannum. Okay, these are the topic. So for each alloy, please, you need to discuss on this criteria. The content should be included in your assignment is the introduction, the details explanation regarding to the alloy. Okay, you can have a different set of discussion for the alloy. For example, it is if your alloy involve nickel aluminum alloy, so there must be a several option of alloy, and for each different alloy you may discuss on different composition, whereby in the different composition will give a different discussion. For example, the phase transformation. So I would like to assess your knowledge regarding to discuss on the phase transformation. For example, in the plumbum stannum system, in fact, in the application of this alloy, there are one particular alloy that basically is being used for this the application of soldering materials. Okay, for the soldering materials, it's contain eutectic composition. Because why? Because it has a lowest melting point. But however, some improvement has been made for the hyper-eutectic alloy, whereby it increased the composition of stannum around 70%, plus other alloying elements. The melting point slightly increased. The reason they increase this composition because they want to increase the reliability of the soldering material. So you may choose, maybe you don't know the application. For example, should I choose eutectic alloy and 70%, and why should I choose 70% and 30%? It can be directed by information that you found from the internet for a specific application, or else you just choose a different category of alloy. For example, you want to discuss on hypoeutectic alloy. Okay, just to show a different your understanding on different category of alloy. For example, hypoeutectic you get one, and then another one at exactly at the eutectic, and then hypoeutectic, and then some containing single phase of terminal alloy, a terminal phase, and another one at another terminal phase on the right side, something like that. Also, no problem, because the assessment focusing on how far you are able to discuss on the phase transformation for this particular alloy system. Okay, so I hope you clear on this one, because this is the only course that evaluates your understanding on the phase diagram. Okay. Again, I would like to repeat the method of improvement. How your alloy is being improved. You need to find any improvement has been studied to increase the performance of the alloy. And then references. Okay, please learn how to write proper references. Okay, do not just copy and paste the link. No, Okay, there is a format on writing references. For example, if you look at through my window here, okay, for example, nickel, aluminum, alloy, improvements, whatever. I just want to show you what is a relevant references. Okay, basically, when we try to find a research work in the previous published paper or published publication, we always look at the this one scholarly article because it is a scientific article. Do not go to any website, especially the top search that you obtain or found out in the Google, because uh, you need to understand that the concept of search engine, they want to promote, they are making profit through the advertisement. Some okay, my search engine is being trained for scientific work, so it is very rare for me to obtain any commercial advertisement. Okay, but there are some uh, looks like um, um, uh, influenced by the adverts finding. For example, like Springer, Hindawi, something like this. They are promoting their journal. They are boosting through the advert also. So that's the reason sometimes you find some article, some publications obtain at the top search results. However, please go to this scholarly article. This is directly filter your finding through the scientific reports. Some of them you may obtain through the original website links. Some of them include the PDF, meaning that the paper that you can read the full paper. Some of them you need to log in through the UTM website. Okay, so do you know how to search or getting access to the UTM library, pusat sumber PSZ library? Do you know how to get access off campus UTM library?
Tak berapa nak tahu tak?
All right, it is very easy. Use the Mr. Google. PSZ UTM off campus, so that you can refine your search to only relevant information. Okay, if you use the um, the web page, the database uh, for the scientific works. Okay, so okay, how to get access through the off campus? Yes, this one, off campus login. Okay, so you log in through this one, and you can use your UTM ID, and of course it is consistent throughout all your UTM account. So if you go to this one, and then you can get access to all uh, journal. Okay, for example, uh, saya stop dulu. Okay, saya log in. Sorry ya, lambat sikit dia loading. Okay, I think you must do this for any courses. If you want to find any scientific published paper or textbook or any books, or you want to borrow, because now you cannot go to the library, you need to borrow some materials, you can go to the online database that has been subscribed by UTM. UTM pay millions of ringgit Malaysia to subscribe this all this journal. So make sure you make use of it. Okay, for example, okay, you never uh, okay, uh, basically you don't realize now, but if you are doing your final year project, these are the list of database that you are going to use frequently. But you please, actually it is not started with final year project. It is actually you have to train yourself begins to use this material for report writing, assignment, um, many others, because uh, these work are originally published or produced by scientists and engineers all over the world. Okay, since maybe 100 years ago. Okay, so please. So for example, the most let me refine the search material for you. Okay, for example, number one, the American Society of Mechanical Engineer Digital Library. Okay, something related to standard, and then maybe that one is not as much as other resources, but uh, you still can have some from ASME. And then the rest, number two is Science Direct Journal, and number three is Corpus. Web of Science is just a database, but still, if you want to directly go to the journal, you need to, uh, they will assign respective resources. For example, Springer or Science Direct. But for the journal, I would like to advise you to go to the Science Direct Journal. Okay, if you go to the Science Direct Journal, you can find there are millions of journals. Okay, so maybe the power of search engine for the Elsevier or Science Direct like this is not as good as Google search engine. So my advice is you use both application. One is Google Scholar. This is Google has so many application in the search engine, but such as apa ya game or picture or video or specific for images. But this one, Google search engine, just for the scientific publication, they call it Google Scholar. So from the Google Scholar you can have the most relevant to your search material. So from here, let's say you can see this number one, ductility improvement of zinc, zirconia, copper, nickel, aluminum, glassy alloy. Okay, for example, you want to have this material. If you click these materials, perhaps okay, this one is good, meaning that you can directly obtain or download your PDF file because it is already open source, open access. Okay, so you don't have to request or subscribe to access this material. So okay, this is good. In case you are asked to get a permission or you have to pay for the materials, you can search exactly the title, which is this ductility improvement. You search, or you can go directly to the DOI number. DOI number is a very unique and special number assigned for any scientific journal. So you copy this link, you can search here. Okay, you can choose what is the elements for the uh, 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 search information, like volume, issues, journal name, author name, keywords. Okay, there is a advanced search here. Okay, you can use DOI number. Ada tak? Saya silap. Oh, tak ada lah pula DOI number. Anyway, you can use the exactly the title here. Okay, for example, like this. Then you search the information. See, you can have this, and directly you can download the paper. All right. The discussion, the results, and everything you can include in your presentation. Okay, in your report. Okay, it is a very very comprehensive and detailed discussion. You can learn how people improve. For example, like improvement of the ductility. What is the improvement has been made? Okay, for example, it's add a alloying element, and what is the proof that by adding the alloying element, for example, like this one, okay, the alloying elements being added here is nickel, with the X portion of nickel being added in the alloy. Okay, X. What is X? X is defined as 0, 5, 10, and 15 weight percentage. And by modifying, okay, or tailoring the composition of nickel with 0 mean without the addition of nickel, 5 is 5 weight percentage of nickel, 10 and 15, so forth. And then um, what is the assessment that is being analyzed? For example, the cycle, remelting time, how many cycle, okay? Because maybe in this study, they want to see how much the materials can be remelting. Maybe, I don't read this paper. And what else? The Chappie impact value. This is mechanical properties. How? By adjusting the composition of alloy, meaning that you want to improve the materials, right? For this case, it is actually zirconium copper alloy. Okay, the alloy is zirconia and copper, and they adjust another uh, 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 third third element is aluminum, is not being adjusted, but not fourth element, which is nickel. They just add 5%, 10%, and 15% to see how much it can be improved. All right. But so if you look at this result, you can discuss this. You can include this data saying that by adjusting, okay, or optimizing the fourth element in the alloy system. Okay, it can be third element, it can be fourth element, but I found this paper, so I would like to show you how we discuss on the improvement of mechanical properties. See, the impact value, meaning that it's being improved in terms of the toughness. Why? Because it discussing or it study on the impact value. Chappie impact is one method to test the toughness, how much the impact load, okay, the energy can be absorbed by the materials. Okay, look at the result. See, the impact load is changed with the remelting time. What is remelting time? I don't know. Okay, you need to read. So by adding 5%, it seems like it shows um, some improvement as compared to zero. What is zero? Zero is this one. Zero is a circle. A square is 5%. Diamond is 10%, and triangle is a 15%. So we can see that even though we increase up until 15, but the 15% of nickel alloying element is not the best. Okay, it shows the best performance at 10% of nickel. So this kind of improvement is can answer the requirement of your report content for the improving of materials properties. Okay. So when you talk about improvement method, you can search several methods. Just now, I have mentioned about adding a third element or fourth element, meaning that through a alloying process. Besides, you can include also other methods, because remember, you have learned about 4 category of strengthening mechanism. Okay, number 1 is grain refinement. Number 2 is alloying. Number 3 is strength hardening or cold working process. And number 4 is heat treatment process or precipitation hardening. You cannot just simply list down all 4 processes if it is not relevant. Okay, make sure when there are 2 or 3, you clearly highlight what exactly. For example, for chromium copper alloy just now, uh, zirconia copper alloy, it clearly shows that alloying process has been conducted to see how much the impact log can be improved. See, you just not explain every possible process, no, but must be relevant to your alloy. Okay, if it is zirconia copper, so clearly mention about how this method really improve the mechanical properties, such as what properties you want. Okay, so like that. Any question before you go to your respective breakout session?
Doctor,
Yes.
I want to ask the reference tarikh dia mesti 10 tahun ke? Macam tempoh reference tu. Mesti 10 tahun ke?
Masih 10 tahun. Kenapa awak cakap macam tu?
Macam
Uh,
ni validity dia.
latest. Sebab
Yes.
kadang nak yang latest ke macam mana?
Alright. For example, like this journal, okay. This is 2003, 2003. So kalau 10 years back is 1993. If you look at this reference, you can see 1995 is still less than 10 years. 1997, 2002, but 1987. Look at 1970. Okay, some of the references, you need to use the ancient references. For example, the first zirconium copper has been developed in 2001, for example. It is more than 10 years ago. Okay, you can use both actually, but you cannot say you cannot cite every references uh, with the very old references, because for example when you discuss, okay, recently, for example, you talk about the recent development, recently the new alloy has been developed for copper aluminium, and then your citation is 1980, tak relevant lah kan, betul tak? Is that true? If you are talking about the very basic and the first theory has been developed, yes, you can use very old references. But when you talk about a new development, you talk about new application. For example, you said that, okay, my alloy has been used for many application, for example, A, B, C, and suddenly all the A, B, C is a very old application, nothing new. Okay, that one is not a good report lah. If you want to talk about application, please find the, of course, for example, you talk about stainless steel. Okay, you bagi example. For example, the application in the construction development, and then your material is 50 years back. Okay, whereas there are so many application study on that particular construction application reported in 2020, for example. So kenapa you not cite 50 years back? Of course, you want to use the most recent development. Okay, so like that. Please avoid use very old references. And if you want to use a very old references, it must be logics. Okay, must be common sense lah. You follow the common sense. Macam as I mentioned just now, it is really relevant to very old references. For example, when we talk about old reference, okay, for example, number one, why? Okay, for example, you talk about history. Okay, it has been developed since it is first developed in 1950, for example. Yes, you can cite. And then the application, yes, but not all application mentioning about very old references. Okay, it can be both old and new. Okay, if possible, try find the letters, even though it is similar. For example, stainless steel for construction material. Okay, construction materials. Okay, you can use citation all and new one. Okay, you can, for example, at this point, you talk about okay, yeah, in the introduction, basically in the introduction, um, Okay, for example, you talk about, okay, for example, core rolling process, 1 to 11, 12, 11 reference. Okay, like this one. All right, code rolling. Um, there are 11 and 12 citation has been assigned for this particular information. So one can be old reference. Second reference can be new reference. That one is very, that's very dynamic references lah you use. And then citation reference format, please follow exactly um, a proper reference format lah. Okay, how to write a reference. Jangan copy paste all the links that you obtain from here like this one. Do not copy paste like this. Okay, this is not the right format. All right. If you look at this website, okay, you can easily or in fact in this one you can easily export the citation, whatever the format that, the application you use. Okay, for example, in my Microsoft Words or Microsoft Words, I usually use EndNotes, and for the EndNotes we use the RIS format. Okay, RIS. You need to learn from now, because later on you have to use this and get used to this for the thesis report. Or if you don't use any because of the limitation of computer or the software that you use, you can just export citation to text. Okay, if you export the citation to text, you can have this kind of information. Okay, which is you have the name, how they write the names, the article name, the journal. So you manually arrange this information. Okay, the author name, the title, the volume, the year of publication, or whatsoever. Make sure you follow the standard, whatever the references format that you use, APA, Harvard, UTM, or whatsoever. Make sure it is consistent. Okay. So for example, like this one, it use one format standard, okay, for the citation, so that it consistent. How? Okay, the name of the author, there's no title. The method trans is the publication name, GIM. What is GIM? Method trans GIM. Okay. The method trans GIM is the journal name. 36 is the volume, year 1995, and 391 is the page number. Okay, this is consistent format throughout all the references list. Okay, so lagi ada soalan lagi? Anything else?
Doktor, saya punya slide je kan. Tak perlu report panjang.
Yes, slide. Tak perlu report. Even though you prepare slides, okay, for example, like this one, okay, you have this alloy system, and then you explain about, ada tak contoh assignment student. Let me see. Contoh assignment student kenapa saya ambil tu? Saya cari yang good assignment. Okay, for this one, okay, this is just copy and paste everything. I think from one resources only. Okay, for example, there's so many statements here. Why don't you any point, for example, benda lah yang dia bagi ni. Alright, for example, like this one, you have you retrieve this image from any published paper or any resources. You put the references here. Okay, for example, reference number 1, number 2, number 3, and so forth. And then at the end of the slide presentation, you list down all the references like this. Okay. So this one is considered consistent reference lah ni. And then ada tak good? Tak adalah. Kalau ada nanti saya share good assignment. Okay. So anything else? Lagi tak? Kalau tak ada, kita start session masing-masing, discuss. Oh. Ya.
Saya tanya untuk phase diagram, kami kena discuss dua alloy macam hypoeothetic dengan eothetic alloy tu. Macam
More than one lah, to show how far you understand your alloy.
faham.
Jangan satu je lah. Satu je macam sikit sangat ni. Tak ada dah. If you have no more question, I think let's go to your respective breakout sessions, and I will visit from time to time. Okay, please discuss, assign the task or whatsoever among your group member, and I will stop the end the session by 4 o'clock. Okay.